According to IUPAC system, if you want to name any organic compound, you don't need to require its history as well as source. You require certain rules and regulations. What is the general formula of alcohol? General formula of alcohol is ROH. ROH. The double bonded carbon atoms are attached with same atom or same group of atom. Unsymmetrical, the double bonded carbon atom is attached with two different group of atom. Hello, my dear students. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear students, last session, that is in the first session, I discussed about the chapter Haloalkanes and Haloarenes. In that, I discussed about introduction, classification, monohaloalkane, dihaloalkanes as well as what? Polyhaloalkanes. In that session, I completed introduction and classification. The second session of same chapter, that is haloalkanes and haloarenes. Today, I am going to explain nomenclature of haloalkanes and haloarenes, nature of CX bond, as well as methods of preparation. First one, I'll explain nomenclature. Second one, nature of CX bond. Third one, method of preparation. Today, content is nomenclature, nature of CX bond, method of preparation. Okay, let us consider nomenclature. Nomenclature. As you know, what is nomenclature? Naming of compounds is called as nomenclature. ನಿಮಗೆ ಹೇಗೆ 2-3 ನೇಮ್ಸ್ ಇರುತ್ತೋ ಹಾಗೆ organic compounds also named by two systems. One is trivial system, second one IUPAC system. Today I am going to discuss about the trivial names as well as IUPAC name of few haloalkanes and haloarenes. First compound, the common name, that is trivial name. Trivial name, it is also called as which name? Trivial name. Trivial name or common name. CH3CH2Cl. Cl is chloride. CH3CH2 is ethyl. Therefore, what's the common name? Ethyl chloride. IUPAC name is Cl is chloro. It has how many carbon? 2 carbon. Therefore, the root word is eth, as well as it contains single bond. It is ANE. Therefore, what is its IUPAC name? Chloroethane. What is its IUPAC name? Chloroethane. Next, it is isopropyl bromide. Isopropyl bromide. Trivial name is isopropyl bromide. IUPAC name, if I consider this as a parent chain, in the second carbon, bromine atom is attached. Therefore, 2-bromopropane. I'll discuss only IUPAC names. Now, if I consider first carbon, second carbon, third carbon. 3-chloropropene. 3-chloropropene. Now here, if I consider this as first position, second, third, fourth. In second and fourth, there are 2 chlorine atom. That's why it is 2,4 dichloro in methyl benzene. Methyl benzene. What is methyl benzene? CH3. Now, if I put this as first carbon, second carbon, third carbon, fourth carbon, it is 2-chlorobutane. It is 2-chlorobutane. Next, similarly, if I put 1, 2, 1 chloro, in second carbon, there are how many methyl? 2 methyl. How many methyl group are there? 2 methyl. Therefore, 1 chloro, 2,2 dimethyl propane. 2,2 dimethyl propane. Here, this is, so when I put CH3, observe here, CH3, Br. I'm split this as, okay. If I put this, I consider as a parent chain, 1, 2, 3. In second position, we have bromine as well as methyl, 2-bromo, 2-methyl propane, 2-bromo, 2-methyl propane. Now, this is first and second carbon, 1-chloroethene. Why it is ethene? Because here it contain double bond. Because it contain double bond. Now here I will give first positions to this carbon, not first position to this carbon. First priority must be given to double bond. Priority must be given to double bond. Second carbon, third carbon. 3-bromopropene. 3-bromo, it's not propane. 3-bromopropene. 3-bromopropene. If I put first position, it is 1-chloro-2-methyl benzene. 1-chloro-2-methyl benzene. This is chlorophenyl methane. Chlorophenyl methane. It is dichloromethane, because you already know there's some rules and regulation how to name any organic compound by IUPAC system by in first PUC. Therefore, you follow that rules as well as put least possible number to the functional group, next number to the substituent, as well as try to write IUPAC name of a given organic compound, that is haloalkane and what? Haloarene. Haloalkane and haloarene. Okay. Next part. Here 3 chlorine atoms are there, therefore it is trichloromethane. 3 bromine atom is there, tribromomethane. 4 chlorine atom is there, tetrachloromethane. Now here if you put first, second and third, it is here fluorine atom is there, it is 1-fluoropropane, and it is Br is there, it is bromobenzene. Bromobenzene. If I put first, second and third position, 1,3 dibromobenzene. 1,3 dibromobenzene. So you have for any organic compound, you have trivial name as well as IUPAC name. To name any compound according to trivial system, you require its source as well as history. But according to IUPAC system, if you want to name any organic compound, you don't need to require its history as well as source. You require certain rules and regulation. Using that rules, apply that rules and try to write IUPAC names of all the organic compounds. All organic compound. Okay. Next. 1, 2, 3, 4, 5, 6. First position, third position and fifth position, there are 3 bromine atom. That's why 1, 3, 5. Because of the presence of 3 bromine atom, it is tribromobenzene. Tribromobenzene. This I'll put first position and second position. In the first carbon, it is attached with how many chlorine atom? 2 chlorine atom. That's why it is called a 1,1 dichloroethane. 1,1 dichloroethane. Now I'll put first carbon atom and second carbon atom. In first carbon atom also chlorine is there. Second carbon atom also chlorine is there. Therefore, I am going to write 1,2 dichloroethane. 1,2 dichloroethane. These are all IUPAC name of some haloalkanes and what? Haloarenes. Okay. Now, today's important topic is nature of CX bond. Okay. Now, when you consider alkyl halide, in alkyl halide, there is a carbon. It is attached with X and it is attached with alkyl group. Attached with what? Alkyl group. If it is attached with one alkyl group, it is known as primary. 2 alkyl group, it is known as secondary. 3 alkyl group, it is known as what? Tertiary. Now, the X is halogen atom, fluorine, chlorine, bromine as well as iodine, and it is more electronegative than carbon. Halogen atoms are more electronegative than carbon. As you know, in the long form of periodic table, the most electronegative elements are halogens. Electronegative elements are halogen. In that, the order of electronegativity is fluorine is more electronegative than chlorine, bromine as well as iodine. This is the electronegativity order of what? Halogen. Now, here X is more electronegative than carbon. This shared pair of electron present which is between carbon and X, shared pair of electron or sigma pair is partially shifted to halogen atom. Therefore, there is a partial negative charge is on X and partial positive charge on carbon. That is, this molecule is polarized. It is, polarized. X can partial negative charge. Carbon atom carries partial positive charge and while halogen carries partial negative charge. Okay. Therefore, the whole alkyl halide molecule is polarized. If you consider halogen atom, fluorine, chlorine, bromine, iodine. In the periodic table, they arrange down the group. As you move down the group, bond length increases, bond energy decreases. Bond length, Bl means what? Bond length. Bond length. B is what? Bond energy or bond enthalpy. Bond energy or bond enthalpy. Therefore, bond energy or bond strength decreases down the group. Therefore, which has maximum bond strength? Maximum bond strength has CF, minimum has CI. Therefore, what is the order of strength of CX bond? CF is more strength than CCl, than CBr, than CI. As the strength and the reactivity are inversely proportional, strength and reactivity are inversely proportional. Therefore, what's the reactivity order? Iodides are more reactive than bromides, than chlorides, than fluorides. Therefore, what's the order of strength of CX bond? The order of strength of CX bond is CF bond strength is more than that of CCl bond, than that of CBr bond, than that of CI bond. So, you have to write reverse order for reactivity. Which is more reactive? Alkyl iodides are more reactive than bromide, than chloride, than fluoride. Remember, this is the key point for this concept. So, down the group, bond length increases, bond energy or bond strength decreases. Bond energy and bond strength decreases. Strength and reactivity are inversely proportional. Therefore, what's the order of strength of CX bond? The order of strength of CX bond is CF is greater than, CF has more bond length, more bond length than CCl, than CBr, than CI. Order of reactivity is RI is more reactive than RBr, RBr is more reactive than RCl, RCl is more reactive than RF. This is about nature of CX bond. Now, the very important, the methods of preparation. How alkyl halides are prepared. This alkyl halides, the starting material, alkyl halides or haloalkanes. Alkyl halides are what? Haloalkanes. The starting material for alkyl halide and haloalkane is alcohol. What are alcohol? Which having functional group OH. Those having functional group OH, they are known as alcohol. The functional group of alcohol is OH. So therefore, alcohols can be converted to haloalkanes by the substitution of OH group by halogen atom. If the OH group of alcohol, if it is replaced by halogen, you are going to get haloalkane or alkyl halide. Hagare, what are alcohols? Alcohols are the organic compounds whose functional group is OH. What is the general formula of alcohol? General formula of alcohol is ROH. So, the OH group of alcohol, if it is replaced by capital X, what is capital X? Already I explained in session 1, capital X is halogen atom, fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. If OH is replaced by X, it is called we'll get haloalkane. Okay. It can be done by adding halogen acids. General formula of halogen acid is HX, halogen acid. But while adding halogen acid, you have to add dehydrating agent like either anhydrous zinc chloride or concentrated H2SO4 or H3PO4 or H3PO4. Either you can use anhydrous zinc chloride, or one we can use concentrated sulfuric acid, or one we can use H3PO4. Okay. Now, what's the general formula of halogen acid? HX. HX means either HCl, HBr, HBr, HI, HCl, HBr, HI. The general formula of halogen acid is HX. So, how do you convert alcohols into alkyl halides? What's the general formula of alcohol? General formula of alcohol is ROH. ROH. How do you convert alcohol into alkyl halide? By replacing OH group of alcohol by X. It can be done by the action of halogen acids. By the action of halogen acids. By the action of what? Halogen acid. Halogen acid general formula is HX, either HCl or HBr and HI. You have to add dehydrating agents. First one anhydrous zinc chloride, second one concentrated sulfuric acid, third one H3PO4. H3PO4. Now, take ROH, alcohol. It is the general formula of alcohol. What is the general formula of alcohol? General formula of alcohol is ROH. What's the general formula of halogen acid? Halogen acid. So, it is HX. In the presence of one you can use, what are that? Three options are there. Anhydrous zinc chloride, concentrated sulfuric acid, H3PO4, you will get RX. You will get RX. What is RX? Alkyl halide. Alkyl halide or haloalkane. Alkyl halide, or it is what? Haloalkane. So, when alcohol is heated with halogen acid in the presence of dehydrating agent, you are going to get alkyl halide. First, we will prepare preparation of alkyl chloride. Alkyl chloride is its trivial name. Chloroalkane is its IUPAC name. Alkyl chloride is its trivial name. Chloroalkane is its what? IUPAC name. How alkyl chloride? As you know, if you want to introduce chlorine group, you have to take which acid? You have to take HCl. You have to take HCl. See, now I want to prepare alkyl chloride or chloroalkane. You have to introduce which atom? Chlorine atom. If you want to introduce chlorine atom means you have to take HCl. You have to take HCl. If you want to introduce bromine atom, you have to take HBr. If you want to introduce iodine atom, you have to take HI. Here I want to introduce chlorine atom in case of chloroalkanes. That's why I have to take HCl. When you are going to take HCl, which is used as dehydrating agent, when there is HCl as a reactant, the dehydrating agent is anhydrous zinc chloride. Anhydrous zinc chloride. So, it acts as dehydrating agent and favors the forward reaction, and it favors what? Forward reaction. Therefore, what is the equation? One we can write. One we can write here. ROH. We are preparing chlorides. Therefore, HCl in the presence of anhydrous zinc chloride. Here OH must be replaced by Cl. Therefore, H and OH water, and it will become what? RCl. Alkyl chloride is obtained. Anhydrous zinc chloride, don't think that any substance which is written on the arrow mark, it is always act as catalyst. It is not catalyst here. Anhydrous zinc chloride is a dehydrating agent. What is dehydrating agent means? It is used to absorb water. D means removal. Removal of water. A substance which is used to remove water, such reagents are called as what? Dehydrating agent. They are called as what? Dehydrating agent. Anhydrous zinc chloride used as dehydrating agent. Once again I will repeat. So, now we are prepared alkyl chloride or chloroalkane. How do you convert alkyl chloride And how do you obtain alkyl chloride and chloroalkane? Take starting material as alcohol. What's the general formula of alcohol? General formula of alcohol is ROH. It is treated with HCl in the presence of anhydrous zinc chloride as a dehydrating agent. You are going to get RCl plus water. Now, the very important for your MCQ or 1 mark question, the mixture of HCl and anhydrous zinc chloride is known as Lucas reagent. Is known as what? Lucas reagent. The 1 mark very important question. What is Lucas reagent? What is Lucas reagent? Lucas reagent is a mixture of HCl and anhydrous zinc chloride. Next chapter of your organic chemistry, that is second chapter of organic chemistry, alcohols, phenols and ethers. I am going to take once again the name of Lucas reagent, because Lucas reagent is an important reagent which is used to distinguish between primary, secondary and tertiary alcohols. Primary, secondary and tertiary alcohols are distinguished by using which reagent? Lucas reagent. Here, what's the use of Lucas reagent? Here the Lucas reagent is used as dehydrating agent. But next chapter, the second chapter of your organic chemistry, same Lucas reagent I am going to use to distinguish between primary alcohol, secondary alcohol as well as tertiary alcohol. Now, what is the general equation? Alcohol is ROH, HCl, anhydrous zinc chloride. RCl is alkyl chloride, or it is chloroalkane, this is alcohol, this is alkyl halide, and this process is called as Gru's process. This process is called as what? Gru's process. Which is known as Gru's process? Conversion of alcohol into, it is alkyl chloride. The conversion of alcohol into alkyl chloride. Conversion of alcohol into alkyl chloride is called as Gru's process. The mixture of HCl and anhydrous zinc chloride is called as what? Lucas reagent. Is called as what? Lucas reagent. My dear student, in case of organic chemistry, just you learn general equation. No need to by heart the example, because if you know the concept of for which general group you have to substitute which group, it is very easy. For example, here R, already you know that R is alkyl group. Alkyl means methyl. Methyl is CH3. Next ethyl, CH3, CH2. Propyl, CH3, CH2, CH2 is known as what? Propyl. Therefore, wherever is there, either you put methyl or what? Ethyl. Now here in place of R, I had taken ethyl. What's the formula of ethyl? CH3, CH2. Therefore, example CH3, CH2OH plus HCl plus HCl, it will give rise to CH3, CH2, HCl plus H2O This is general equation and it is example. And what's the name of this reaction or process? It is known as Gru's process. It's known as what? Gru's process. And the mixture of HCl and anhydrous zinc chloride is known as what? Lucas reagent. Now, similarly, can you tell me how do you prepare alkyl bromides? Same, take ROH. Alkyl bromides means you add HBr in the presence of concentrated H2SO4. Instead of anhydrous zinc chloride, I will take concentrated H2SO4. Here OH, here I will remove H. It will give rise to what? H2O plus RBr. RBr. Example, in place of R, I will put CH3, CH2. CH2OH plus HBr, OH and H, it gives rise to water, and in the presence of concentrated sulfuric acid, product is CH3CH2Br. It is ethyl alcohol. It is ethyl alcohol. It is ethyl bromide. Ethyl bromide is its trivial name. Bromoethane. Bromoethane is its IUPAC name. This is, I prepared which one? First I prepared alkyl chlorides. Now I will prepare alkyl bromides or bromoalkanes. Bromoalkanes. Okay. Next, prepare alkyl iodides or iodoalkanes. For that you take ROH plus HI in the presence of H3PO4, you will get Ri plus H2O, remove OH and H, Ri. In example, in place of R, you put ethyl. Now here also it will become what? In place of R, you put ethyl. Therefore, you will get ethyl iodide. Therefore, what's the first method? I converted alcohols into alkyl halides by adding HX. What is HX? Halogen acid. If I add HCl, we'll get alkyl chloride. If you add HBr, we'll get alkyl bromide. If you add HI, we are going to get alkyl iodide. But in the same reaction, don't use same dehydrating agent. In case of HCl, you use anhydrous zinc chloride. In case of HBr, you used concentrated H2SO4. In case of HI, you use H3PO4. The mixture of HCl and anhydrous zinc chloride is called as what? Lucas reagent. Second method, to convert once again alcohol into alkyl halide, you add phosphorus halide. What's the formula of phosphorus halide? PX5. But in phosphorus halide, there is only existence of phosphorus pentachloride. There is no PBr5 and PI5. Only we have PCl5. Therefore, ROH is treated with PCl5. OH is replaced by one Cl. Therefore, how many Cl are left? 4. In that, PCl3 take O and it will form POCl3. Rest is what? HCl. Therefore, what are the byproducts formed during when you add PCl5 to alcohol? POCl3 plus what? HCl. Therefore, when alcohol is heated with phosphorus halide, alkyl halide is formed. How do you prepare phosphorus pentachloride? Chloroalkane is obtained by treating alcohol with phosphorus pentachloride. Here I am not going to write example for every reaction because already I explained that in place of R, you put alkyl group either methyl or ethyl. Next, by using phosphorus trihalide with phosphorus trihalide. When phosphorus trihalide, what's the general formula of phosphorus trihalide? PX3. PX3 will get, when alcohol is heated with PX3, will get what? RX. Will add PCl3, PBr3, PI3. PCl3 ಹಾಕಿದಾಗ will get ಏನು ಬರುತ್ತೆ? RCl. PBr ಬಂದಾಗ ಏನು ಹಾಕುತ್ತೆ? RBr. PI3 ಬಂದಾಗ ಏನು ಬರುತ್ತೆ? RI. How can you prepare PBr3 and PI3? PBr3 is prepared by heating red phosphorus and bromine. PI3 is obtained by heating red phosphorus and bromine. As you know, phosphorus has different allotropic forms. Red phosphorus, white phosphorus as well as yellow phosphorus. Therefore, here we have to use which type of phosphorus here? Red phosphorus. If you want to chloride, you add PCl3. If you want to Br, you want to PBr3. If you want Ri, you add PI3. So what is the byproduct obtained here? H3PO3. What's the byproduct obtained here? H3PO3. Therefore, in PX5 only we have PCl5. But in PX3, you have 3. One is PCl3, one is what? PBr3, one is what? PI3. PbR3 and Pi3 is obtained by heating red phosphorus plus bromine. Here red phosphorus plus what? Iodine. Red phosphorus and iodine. When you add PCl5, what are the byproducts? What are the byproducts? POCl3 plus HCl. POCl3 and HCl. In phosphorus trihalide, what is the byproduct? H3PO3. What is the byproduct? H3PO3. The byproducts also important. Main product is alkyl halide. Main product is alkyl halide. Byproduct in case of PCl5 is POCl3 and HCl. In case of PCl3, PbR3 as well as Pi3, the byproduct is H3PO3. H3PO3. So now these are the two methods. When one which you convert alcohol into alkyl halide. First method, how do you convert alcohol into alkyl halide? By adding HX. By adding HX. Second method, how do you convert alcohol into alkyl halide? Either by adding phosphorus pentahalide and phosphorus trihalide. In phosphorus pentahalide, we have only one pentahalide, that is PCl5, phosphorus pentachloride. But in case of phosphorus tribromide, we have three trihalides. One is phosphorus trichloride, phosphorus tribromide and phosphorus triiodide. Triiodide. This is bromoalkane, ROH with red phosphorus, where X2 is bromine as well as what? Iodine. Okay. Next, using thionyl chloride. Using thionyl chloride. The formula of thionyl chloride is SOCl2. Formula of thionyl chloride is SOCl2. Alkyl chloride can be obtained by heating alcohol with thionyl chloride in the presence of pyridine. In the presence of pyridine. What's the role of pyridine here? Pyridine is not used as catalyst here. See, my dear student, don't think that any substance which is written on the arrow mark, it is always act as catalyst. Here, what is the use of pyridine? Pyridine is used to neutralize this HCl. HCl formed during this reaction, it can be neutralized. It can be neutralized by adding what? Pyridine. What's the formula of thionyl chloride? SOCl2. SOCl2. Example, in place of R, you put CH3CH2. So, what is the explanation one we can give for this? When alcohol is heated with ROH means alcohol. When alcohol is heated with thionyl chloride, it will give rise to alkyl chloride. What's the use of pyridine here? Pyridine is used to absorb or neutralize HCl. This process is called as Darjan's process. This process is called as what? Darjan's process. ಯಾವ process students? ಈ process ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Darjan's process. ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಇನ್ನೊಂದು process ಹೇಳಿದೆ. ಅದು ಯಾವ process? Gru's process. Gru's process ಗೂ Darjan's process ಗೂ similarity ಏನು? We are converting alcohol into alkyl chloride. Alcohol into alkyl chloride. What's the general formula of alcohol? ROH. What's the general formula of alkyl chloride? RCl. Our intention to convert alcohol into alkyl chloride by adding HCl, here by adding thionyl chloride. Thionyl chloride. There HCl in the presence of anhydrous zinc chloride. Here thionyl chloride in the presence of what? Pyridine. That process is called as Gru's process. This process is called as what? Darjan process. What's the use of pyridine here? Pyridine is not used as catalyst. Pyridine not used as dehydrating agent. Pyridine is used to neutralize HCl. Used to neutralize HCl, and this process is called as what? Darjan's process. This process is Darjan's process. Okay. We use thionyl chloride. Why can't you use to prepare bromides? Thionyl bromide and thionyl iodide. Thionyl iodide does not exist. ನಿಮಗೆ thionyl iodide ಅಂತ ಕಾಂಪೌಂಡೇ ಇಲ್ಲ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? It does not exist. It does not exist. Thionyl bromide, although it exists, it is unstable. It is unstable. Therefore, alkyl bromides and alkyl iodides cannot be prepared from thionyl bromide and thionyl iodide. Only one we can prepare alkyl chloride. Alkyl chloride by using thionyl chloride. By using thionyl chloride. Therefore, here we can't use thionyl bromide as well as what? Thionyl iodide cannot be used. Why? Thionyl bromide is unstable. Thionyl bromide is unstable and it does not exist. It does not exist. So, this is the preparation of what? Alkyl halides starting from alcohol. Starting from alcohol. Okay. Next, Roman number 2, from hydrocarbons. From hydrocarbon. Okay. In hydrocarbons, you know that we have alkanes, alkenes and alkane. But here we'll consider alkanes. We'll consider alkanes. Last year in the first PUC, we discussed about alkanes undergo substitution reaction. When it undergoes substitution reaction, when it reacts with halogen, it is known as halogenation. In that, we studied about chlorination. Methane undergo chlorination in the presence of diffuse sunlight, and that reaction is called as free radical halogenation. Free radical halogenation. Why then it is called as free radical halogenation? During this reaction, the reaction intermediate formed is free radical. Reaction intermediate formed is free radical. What is free radical? Free radical is a fragment carrying one electron or odd electron. One electron or odd electron. What is free radical? Fragment carrying one electron or odd electron. Therefore, here free radical chlorination or bromination of alkanes gives a complex mixture of mono and what? Polyhaloalkane. Mono and polyhaloalkane. When mono and polyhaloalkanes are formed, the separation is very difficult. Separation is very difficult. Here, I'll consider N-butane. It is what? N-butane. How can you say it is N-butane? It has 4 carbon atoms. It reacts with chlorine in the presence of sunlight. In the presence of sunlight. Here, the first carbon is replaced by chlorine as well as second carbon also replaced by chlorine. Here we will get 1 chlorobutane and 2 chlorobutane. We get a mixture of 1 chlorobutane and 2 chlorobutane. When we get a mixture, isomeric mixture, it is very difficult to separate. Okay. So this is called as free radical halogenation. Next, B. A is alkanes. B is alkenes. Alkenes mean which containing carbon-carbon double bond. This can be done by adding hydrogen halide. Hydrogen halide general formula is HX. Either you take hydrogen chloride, hydrogen bromide and hydrogen iodide. Now here I consider ethene. I'll add HI. Ethene is a symmetrical alkene. It is a which type of alkene? It is symmetrical alkene. Observe here, the double bonded carbon is attached with same atoms. If in alkene, there are 2 types of alkene, symmetrical alkene and unsymmetrical alkene. What is symmetrical alkene? The double bonded carbon atoms are attached with same atom or same group of atom. Unsymmetrical, the double bonded carbon atom is attached with 2 different group of atom. Now ethene is very beautiful example for symmetrical. Observe here double bonded carbon atom. Here also it is attached with H2. Here also it is attached with H2. Therefore it is symmetrical. If H is plus, I is minus. Take H to one side, I to another side. It will become CH3, CH2I. Therefore it is ethyl iodide. It is what? Ethyl iodide. Okay. Now, the very important is, in case of unsymmetrical alkene, the hydrogen halide added according to Markovnikov's rule. According to which rule? Markovnikov's rule. Which rule? Markovnikov rule. Okay. Therefore, Markovnikov rule applicable only for which type of alkene? Unsymmetrical alkene. If it is symmetrical alkene, when hydrogen halide is added, no need of Markovnikov rule. If alkene is unsymmetrical, the addition of hydrogen halide takes place according to Markovnikov rule. What is the statement of Markovnikov rule? Now it is propene. My dear student, observe here. 1, 2, 3. This is double bonded carbon atom. Here, the double bonded carbon is attached with H2. Here, double bonded carbon atom is attached with CH3 and H. It is attached with double bonded carbon atoms are attached to different groups. Now, I will consider double bonded carbon atom. I am not going to consider single bonded carbon. H is plus, I is minus. What is the statement of Markovnikov rule? When hydrogen halide added to unsymmetrical alkene, the positive parties get attached to carbon carrying more number of hydrogen. Positive parties get attached to carbon carrying more number of hydrogen. Negative ಏನಾಗುತ್ತೆ? It goes to carbon carrying less number of hydrogen. ನೋಡಿ ಇನ್ನೊಂದ್ಸರಿ ನೋಡ್ಕೊಳ್ಳಿ. CH3 CH double bond CH2. I'll add HI. Don't consider this carbon because it is attached with single bond. Now let's consider these two carbon. This is first and this is second. It carries 2 hydrogen. It carries how many hydrogen here? 1 hydrogen. Plus goes to carbon carrying more number of hydrogen, minus goes to carbon carrying less number of hydrogen. Therefore, CH2 become CH3, CH become I. 1, 2, 3. 2 iodopropane. 2 iodopropane. In form agute 2 iodopropane. 2 iodopropane. Therefore, what is the statement of Markovnikov rule? When hydrogen halide is added to unsymmetrical alkene, the positive parties get attached to double bonded carbon which carrying more number of hydrogen. Okay. In place of HI, if I use HBr, in the presence of peroxide as a catalyst, in the presence of what? Peroxide as a catalyst, use only HBr. ಮಕ್ಕಳೇ ಇಲ್ಲಿ HCl ಮತ್ತೆ HI ನ ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, ಬರೀ ಯಾವ್ದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು? HBr ಮಾತ್ರ. ಕೇಳಿಸ್ಕೊಳ್ಳಿ, HCl ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, HI ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ, ಬರೀ ಯಾವ್ದನ್ನ ಯೂಸ್ ಮಾಡಬೇಕು? HBr. ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಪೆರಾಕ್ಸೈಡ್, ಯು ಟೇಕ್ ಎನಿ ಬೆಂಜೈಲ್ ಪೆರಾಕ್ಸೈಡ್ ತಗೊಳ್ಳಿ, ಡೈಬೆಂಜೈಲ್ ಪೆರಾಕ್ಸೈಡ್ ತಗೊಳ್ಳಿ, ಅಸಿಟೈಲ್ ಪೆರಾಕ್ಸೈಡ್, ಎನಿ ಆರ್ಗ್ಯಾನಿಕ್ ಪೆರಾಕ್ಸೈಡ್ ಯೂಸ್ಡ್. ಸೊ ಹಿಯರ್ ದ ಅಡಿಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಅಗೇನ್ಸ್ಟ್ ಟು Markovnikov rule. Against Markovnikov rule ಅಂದ್ರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ಆಂಟಿ Markovnikov rule. Against Markovnikov rule ಅಂದ್ರೆ ಏನ್ ಮಕ್ಕಳೇ? ಆಂಟಿ Markovnikov rule. ಏನ್ ಆಂಟಿ Markovnikov rule? Markovnikov rule ಅಲ್ಲಿ ಪ್ಲಸ್ ಎಲ್ಲಿಗೆ ಹೋಗ್ತಿತ್ತು? ಕಾರ್ಬನ್ ಕ್ಯಾರಿಂಗ್ ಮೋರ್ ಹೈಡ್ರೋಜನ್. ಆಂಟಿ Markovnikov rule ಏನಾಗುತ್ತೆ? ಪ್ಲಸ್ ಗೋಸ್ ಟು ಕಾರ್ಬನ್ ಕ್ಯಾರಿಂಗ್ ಹೈಡ್ರೋಜನ್. ಇಲ್ಲಿ ನೋಡ್ಕೊಳ್ಳಿ, ಇದೇನಿದು? ಪ್ಲಸ್, ದಿಸ್ ಇಸ್ ಮೈನಸ್. Markovnikov rule ಅಲ್ಲಿ H ಪ್ಲಸ್ ಎಲ್ಲಿಗೆ ಹೋಗಿತ್ತು? CH2 ಹೋಗಿತ್ತು. ಆದ್ರೆ ಇಲ್ಲಿ ಆಂಟಿ Markovnikov rule ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಪಾಸಿಟಿವ್ ಗೋಸ್ ಟು carbon carrying less number of hydrogen, negative goes to carbon carrying more number of hydrogen. It is completely against to which rule? Markovnikov rule. But Markovnikov rule only for which one? Hydrogen bromide. It is not applicable for HCl and what? HI, as well as there is a requirement of peroxide as a catalyst. If anti-Markovnikov rule addition takes place according to anti-Markovnikov rule, this effect is called as peroxide effect. This effect is known as what? Peroxide effect or Karasch effect. It is also called as what? Karasch effect. So peroxide effect, or it is known as what? Karasch effect. Allige, what is the statement of Markovnikov rule? Plus goes to carbon carrying more number of hydrogen. If plus goes to carbon carrying less number of hydrogen, it is anti-Markovnikov rule. Markovnikov rule and anti-Markovnikov rule both applicable only for which type of alkene? Unsymmetrical alkene. But in case of anti-Markovnikov rule, only which one must be applicable? HBr in the presence of organic peroxide as a catalyst. Organic peroxide as a catalyst. Next, addition of halogen to alkenes. Now I'll take bromine. It dissolved in CCl4, carbon tetrachloride. Bromine Br2 written as BrBr. One bromine goes to first carbon, another bromine goes to second carbon. Addition takes place, therefore the double bond will become single bond. Bromine, this first carbon, second carbon. In the first session already I discussed that 2 halogen atoms are present, they are called as dihaloalkane. If both the halogen atoms are attached to the same carbon, it is known as geminal. If both the halogen atoms are attached to the adjacent carbon, it is called as what? Vicinal. It is called as what? Vicinal. Why it is called as vicinal? One bromine is attached to first carbon, second bromine is attached to, it is attached to the adjacent carbon. First carbon, second carbon, 1,2 dibromo ethane. It is called as vicinal. Why it is called as vicinal? Bromine atoms are not present on the same carbon. They present at adjacent carbon. If bromine atoms are present at the same carbon, it is known as what? Geminal. It is known as what? Geminal. If it is attached to adjacent carbon, it is known as what? Vicinal. It is known as an vicinal. So, double bond will become single bond. Therefore, bromine in the presence of CCl4. During this reaction, the reddish brown color discharge. Reddish brown color discharge. Andre reddish brown irad enagate colorless. Therefore, the addition of bromine in CCl4 to the alkene, it is a test for detection of unsaturation. Detection of what? Unsaturation. New practical classes ali, if I'll give two compounds A and B, if you find out which is saturated and which is unsaturated andre, ಎರಡು test tube ತಗೊಂಡು compound A ಮತ್ತೆ compound B ಹಾಕ್ಬಿಟ್ಟು bromine ಎರಡು test tube ಗೆ bromine plus carbon tetrachloride ಹಾಕಿ. ಯಾವ test tube ಅಲ್ಲಿ reddish brown color discharge ಆಗುತ್ತೋ, reddish brown colorless ಆಗುತ್ತೋ, that indicates that compound is what? Unsaturated. Reddish brown color of the bromine remains as it is. That compound is saturated. Therefore, it is called as bromine water test, and it is a test for to detect unsaturation in the molecule. Test in the unsaturation in the molecule. Okay. Next. Halogen exchange method. Last method, halogen exchange. ಹೆಸರೇ ಹೇಳ್ತಿದೆ halogen exchange method ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾನು ಏನನ್ನೂ ಆಲ್ಕೈಲ್ ಗ್ರೂಪ್ನ ಟಚ್ ಮಾಡಂಗಿಲ್ಲ, ಬರೀ ಹ್ಯಾಲೋಜನ್ಸ್ನ ನಾನು ಏನು ಮಾಡ್ತಾ ಹೋಗಬೇಕು? ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಇಲ್ಲಿ ನೋಡಿ ಮಕ್ಕಳೇ, ಕ್ಲೋರಿನ್ ಆರ್ ಬ್ರೋಮೈಡ್ಸ್ನ ತಗೊಂಡು ಎಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಿಸಿ? ಅಯೋಡೈಡ್ಸ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ. ಆಲ್ಕೈಲ್ ಅಯೋಡೈಡ್ಸ್ ಯಾವ್ದನ್ನ ಪಡಿಬೇಕು ನೀವು? ಆಲ್ಕೈಲ್ ಅಯೋಡೈಡ್ are prepared by the reaction of alkyl chlorides are bromide using sodium iodide in dry acetone. Sodium iodide in dry acetone. This reaction is known as Wilkinson reaction. This reaction is known as what? Wilkinson reaction. So take alkyl RX. X ಏನಾಗಿರಬೇಕು? chlorine or ಏನಾಗಿರು? I'll convert chlorides and bromide to iodide using sodium iodide in the presence of what? Dry acetone. For this you write one example, CH3CH2Cl plus NaI in the presence of dry acetone, you will get CH3CH2I plus NaCl. Alige chlorides and bromides are converted into iodide. Just see my dear student, just I change the halogen atom. Either take chlorides or you take bromides. If you want to convert into iodide, add sodium iodide NaI in the presence of dry acetone. This reaction is called as Wilkinson reaction. Your reaction? Wilkinson reaction. Once again I'll repeat, what is Wilkinson reaction? It comes under halogen exchange method. Here we have to convert chlorides and bromides into iodides. Chlorides and bromides into iodide. How do you convert chlorides and bromides into iodide? By heating with sodium iodide in the presence of what? Dry acetone. Dry acetone. Last one, here also convert chlorides or bromides into fluorides. Chlorides and bromides into fluorides. See, the synthesis of alkyl fluoride best accomplished by heating alkyl chloride or bromide in the presence of metallic fluorides such as silver fluoride, mercury fluoride, cobalt fluoride, antimony trifluoride. Best yavudಕ್ಕೆ preference ಕೊಡಿ? AgF. So, R, X, where X is ClR, Br plus AgF. So, you'll get RF plus AgX. Example, In place of R, you put CH3. You put in a CH3. So this reaction is called as Schwarz reaction. Is called as what? Schwarz reaction. Therefore, one is Finkelstein reaction, second one is what? Schwarz reaction. In Finkelstein reaction, one we can prepare alkyl iodides. In Schwarz reaction, one you can prepare alkyl fluorides. One you can prepare alkyl fluoride. Here just we are changing halogen. If chlorine and bromine is replaced by iodine, it is called as Finkelstein reaction. If chlorine and bromine, if it is replaced by fluorine, it is called as Schwarz reaction. In case of Finkelstein reaction, you have to add sodium iodide in the presence of dry acetone. But in case of Schwarz reaction, you should add metallic fluoride like AgF, Hg2F2, COF2 and SbF3. So, this is a halogen exchange method. In halogen exchange method, two important naming reaction are Finkelstein reaction and Schwarz. And it's a very important question for your board. Either most probably every year the repeated question under 2 mark for 2 mark, either they'll ask Finkelstein reaction or they'll ask Schwarz. Other than the student, please focus on this Finkelstein reaction as well as what? Schwarz reaction. It's a very important question for your board. Okay. Therefore, dear student, in this class, I discussed about nomenclature, I discussed about nature of CX bond and discussed about methods of preparation of alkyl halides. Next session, I'll discuss about what the physical and chemical properties of haloalkanes and haloarenes. Okay, goodbye. Thank you.